clock has started. Roger, 0G, I feel fine. Godspeed, John Glenn.
Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground.
New possibilities are opening up for scientific cooperation between countries.
1, 0, 0. Liftoff. Americans return to space as Discovery clears the tower.
Discovery, go and throttle up.
Discovery rocket, go for deploy.
Thank you, and to everybody in the shuttle program, the crew is go for launch.
Roger, nice to be in orbit.
We have followed in their footsteps to get us where we are today.
Good afternoon. I'm Megan Cruz with NASA's Office of Communications, and welcome to Kennedy Space Center on the Space Coast of Florida, where we are once again poised to make history. This time with NASA's Boeing crew flight tests set to lift off on a United Launch Alliance Atlas V rocket from Cape Canaveral Space Force Station's Launch Complex 41 on Monday, May 6th at 10:34 p.m. Eastern Time. NASA astronauts Butch Wilmore and Suni will be the first to fly on Boeing Starliner, making this only the 6th time NASA has flown a new crew transportation spacecraft. And here to speak with all of you about the recently completed launch readiness review, as well as any other updates we have on the mission, are leaders from NASA, Boeing, and ULA, also a launch weather officer from the 45th Weather Squadron. So let me introduce them to you now. No stranger over here, NASA Administrator Bill Nelson. Then we have Steve Stich, Manager, NASA's Commercial Crew Program. Then joining us virtually from Houston, Dana Weigel, Manager, NASA's an International Space Station Program. Back here on the dais, we have Jennifer Buchli, Chief Scientist, NASA's International Space Station Program, Mark Nappi, Vice President and Program Manager, Commercial Crew Program from Boeing. And then Gary Wentz, Vice President, Government and Commercial Programs over at ULA. And then Brian Cizik, Launch Weather Officer, 45th Weather Squadron, Cape Canaveral Space Force Station. Now, each will give brief opening remarks, and then we'll open questions from here in the room as well as on the phone. If you're here in the room, please wait for a microphone to come to you. And then if you're on the phone, you can get into the question queue by pressing *1. Just a reminder, please ask one question and try to keep your questions to today's mission that we're talking about. All right, Administrator, go ahead.
Thank you, Megan. This is a test flight that brings to bear all the things that the title implies. We're testing the vehicle for, in this case, the first time with humans on board. Megan said this has been done 6 times before. So you think of it. The first time humans have flown on a new spacecraft. Started with Mercury, then with Gemini, then with Apollo, the Space Shuttle, then Dragon, and now Starliner. And come next year, it will be the first time that a crew will climb on and will launch on the Orion spacecraft, which will take us around the moon. Because it is a test flight, we give extra attention. They're checking out a lot of the systems, the life support, the manual control, all of those things that you want to be checked out. That's why we put 2 test pilots on board. And of course, the resumes of Butch and Suni are extensive. The other thing to comment about this flight is this is all a part of our commercial activities. So you've already seen commercial crew and cargo to orbit with the Dragon and other cargo vehicles. This will give us that additional capability because we always look for a backup. That's why, if you remember, in the competitions on the spacecraft to be the lander on the moon. NASA had awarded only one, and we insisted that we go to a second competition for a second lander. That's the importance of having two to give you the robust capability of carrying out the mission. And from NASA's point of view, it's a fixed price contract. And we share in the development costs, but then the operation is a fixed price contract. We're doing that as we go to the moon as well. And so we are going to have a whole new adventure. This is very much a part of our exploration of space in what I call the golden age of space exploration. And think about it, since we're going to keep the International Space Station going for another 6 years to deorbit in 2031, think about these spacecraft. They will be able then to service the to and from to the commercial space stations, which we expect to have on orbit by the time we are deorbiting the International Space Station. So it is a historical day. It's a wonderful day. Oh, by the way, one other historical fact. This is the first time since Apollo 7 launch that a human astronaut launch is actually on what used to be the Air Force, Cape Canaveral Air Force Station, and now is, of course, Cape Canaveral Space Force Station. Megan?
Great reminder, yes. All these firsts and milestones that we're meeting today with this flight test. Okay, Steve.
Yeah, thanks, Megan, and thank all of you for being here. Thanks for your interest in our human spaceflight programs at NASA. It's been a busy time since we last talked after the flight test readiness review. That Friday after the review, the crew got into the vehicle, and you heard from Butch and Suni, did a mission dress rehearsal. They were extremely pleased with the vehicle. We checked out the spacecraft, checked out the whole process of getting in and getting suited up and doing comm checks. That all went really well. Have a few things to move around in the cockpit based on Butch and Suni's input, but that went extraordinarily well. We had a couple of items we talked about at that press event after the flight test readiness review that we've closed out. We did some analysis of the forward heat shield separation of Starliner, and that was closed out. We have good flight rationale to go should even one of those parachutes that pull that forward heat shield off not work properly. We have good flight rationale on that. And then there was one valve at the pad that Gary and the ULA team were working on, and that's been swapped out, and we're good to go there. I just got back from Complex 41 this morning. It was really exciting to be out there for me, thinking about flying Butch and Suni on Starliner and the Atlas just in a few days. It was great to see the team and everybody's excitement proceeding toward launch. We had the launch readiness review, and everyone pulled go to proceed. And Gary and Mark will talk about the timeline of rolling out to the pad and getting the vehicle finally ready for flight. As Megan said, the launch time on May 6th is 10:34 p.m. Eastern. And, of course, we've got to have good weather and the vehicle's all checked out, but we'll work through that step by step. And then we plan to dock about 26 and a half hours later on Wednesday early in the morning at 12:46 a.m. Eastern time. It's about a 26 and a half hour rendezvous. The most exciting thing for me about the launch readiness review was at the very end. We heard from Butch and Suni, and they talked about their excitement. And after everybody had pulled go, Butch got on and wanted to say one thing to the team, and he said he's go for launch. And so it is a super exciting time in commercial crew. You know, the LRR is one of the last major milestones. We'll have a Starliner mission management team on Saturday to review a couple final items and talk through the weather, but I don't see any big items coming up there. You know, it's been a busy time, and for me, it's exciting to bring Starliner and the ULA Atlas launch vehicle online. We have been striving, commercial crew, to have two independent space transportation systems. That's been our goal from commercial crew's inception, and we're very close to reaching that goal with the planned launch on Monday. We did a port relocation, and Dana Weigel will talk more about that, but we moved Dragon on orbit to get the port ready, and that's all ready to go. So overall, things are looking good for launch. I know the crew on orbit is excited as well. Mike, Matt, Jeanette, and Alexander about having Butch and Suni on board. We'll take it one step at a time, work our way through the events over the next few days, and when we're ready, we'll launch hopefully on Monday. You know, it's important that we're making history. I feel that a lot as the commercial crew program manager. It was just 4 years ago we brought the Dragon spacecraft online and the Falcon 9 launch vehicle, and here we are now 4 years later bringing another system online. So we've been taking our time to go through everything methodically because it is a test flight and we want it to go well. I'm sure we'll learn something on orbit and learn something during the flight, but our team is checking, double checking everything and making sure we're really ready to go. So I want to thank our entire team on the commercial crew program within NASA, the Boeing team, our international partners, United Launch Alliance. It's been a lot of work to get here. We have a little bit more work to go. We're going to take it one step at a time, and we'll launch when we're ready. And back over to you, Megan.
Steve, thank you so much. Dana, over in Houston again, joining us virtually.
All right, thank you all for joining us today to hear more about this historic mission. This is a really critical milestone for the agency, for commercial crew, for ISS, and also for our international partners who will one day fly aboard the Starliner vehicle. You've heard it mentioned, but just to reemphasize, having two different U.S. crewed vehicles that can travel and take crew to ISS is really important for us. It helps us with any number of different off-nominal scenarios that we could encounter. And so this crewed flight test is a critical stepping stone to reach that broader goal. Steve mentioned it, but on orbit yesterday, Crew 8 got into their crewed Dragon vehicle, and they relocated their spacecraft from the Node 2 Harmony forward port to the Node 2 Zenith port. That frees up that forward port for the Starliner vehicle. Just this morning, the ISS mission management team convened to review our readiness for CFT. Everyone polled go. We only have a couple open items on board. We've got an inspection using the robotic arm of that Node 2 forward docking port, and then we've got to go put the arm in a stowed location. We'll finish that this evening. We're not working any other issues related to the mission, so everything continues to go very smoothly on board ISS. Once Starliner's in free flight, the ISS team will follow along with the performance of the spacecraft. We'll do that evaluation along with the commercial crew and Boeing teams. And then on Tuesday afternoon, evening, we'll have another ISS mission management team to review the overall spacecraft performance and to give the final go for integrated operations and docking. Once Butch and Suni are on board, they'll be there for a little bit over a week. Their primary activities that week are focused on Starliner itself. They'll put it through its paces. They'll look at configuration of the emergency equipment in their spacecraft. They'll also do some other activities that will verify operations that we will ultimately need for some of the longer duration missions. To recap some of the other things that have gone on with ISS, a little over a week ago, Roscosmos did a spacewalk. They deployed some payloads and some external hardware outside ISS. Then last Sunday, we had the undocking of the SpaceX 30 cargo mission. About a day and a half later, that successfully splashed down. SpaceX 30 was carrying about 4,000 pounds of research and scientific investigations back to Earth. We're very much looking forward to this crewed flight test. We're excited to have Butch and Suni on board, and we're really happy that we're making great progress towards our overall goal of having 2 U.S. crewed providers. And with that, I'll hand it back to Megan.
Dana, thank you so much. And, we're talking about having a robust commercial crew program. That'll obviously have an impact on the station, right, Jennifer?
Absolutely. So more crew means more science. So we could not do the science that we do on the International Space Station without it being enabled by the crew. To date, we've done almost 4,000 investigations and serving over 5,000 researchers. The crew is dedicated to conducting the science on ISS, as well as participating in the science themselves. So on this particular mission, the crew members will be part of 2 human research studies and will be carrying hardware on the vehicle to enable another human research study for our international partners, the European Space Agency. The crew is going to be participating in a study called Pilot Egress Fitness. So as we look at going back to the moon and onto Mars, it's really important for us to understand the physiological impacts of spaceflight on crew members, especially as we look at them entering a partial gravity environment. So when will they be able to egress the vehicle? What type of tasks will they be able to do? And this will really feed heavily into the architecture of the missions that we plan, as well as seeing how we can support the crew. Do we need countermeasures? How can we best make them successful on the surface? So after exiting the vehicle, they will do a series of studies and tests where they traverse a ladder. Eventually, this test will evolve into where the crew will do suited EVAs. We're not going to do that for this particular flight. And then we're going to overlay that with their bone and muscle data that we've collected pre- and post-flight to take a look at their performance. The other investigation they're participating in is a spacecraft occupancy risk. This is where we're going to be looking at the forces experienced by crew to help us build better models of what those forces look like for both reentry as well as landing. This is very similar to what's done in the auto industry. We're going to be collecting data pre- and post-flight on the crew, on their physiology, as well as taking a look at things like seat accelerometers, video collected, and even surveys on the crew members' experience. And then finally, the crew is going to be bringing up hardware to support a European Space Agency investigation called Immunity Assay. This is going to be looking at crew members' response and how we see change to the spaceflight environment and their immune system. So in particular, their white blood cells. This one's really interesting because before we've always had to return those samples to the ground, and now we're going to be able to analyze them on board.
Thank you so much. Again, a reminder that this is a test flight of so many different things, not just the vehicle, not just the spacecraft, but also our astronauts as well. Okay, Mark.
All right, thanks everybody for being here today. Today we had the last of a pretty long list of reviews that led up to this, and today's was just like all the rest, and it showed how well aligned and how ready we are for this mission. As of last night, we had 0 constraints to launch. And really all we are looking forward to now is the work that we have to do this weekend to get ready for Monday. That includes, of course, rolling tomorrow to the pad, configuring the spacecraft for launch. So to do that, we'll open the hatch. We'll do some final cargo and configuration for crew ingress. And then we'll do some power up and some health checks to make sure the vehicle's performing properly. Then we go right into launch ops and lead us up until Monday night. We'll have an L-2 day on Saturday, and if necessary, an L-1 day on Sunday. And really the purpose of those meetings is just to make sure the team is got everything they need, review the weather, and just address anything that may come up over those last 2 days. Last thing I'll talk about is really the team's readiness. And boy, I couldn't be more proud of this team. We came back after the holiday, and we had planned to be ready on March 1st. Knowing that our window was sometime in March, April, May, we said, let's just be ready for whenever the International Space Station can accept us. And so we came back after the first of the year, and we had a safety check-in. And we talked to the team, we said, and Butch and Suni came over and shared some of their experiences and told them how excited they were about what was ahead of us. Told the team at that point, we don't have to hit the ground running. Let's just start slow, let's build momentum, and let's peak at the right time. And that's exactly what they've done. We're at peak performance right now. And we're really looking forward to executing this weekend, executing a launch, and executing the mission in the same way that we got here. So thanks to Steve, thanks to Gary, we're ready to go.
Thank you, Mark. Gary.
Good afternoon. Thank you all for participating, tuning in online for this. We're really honored to be prepping for this crewed flight test. and to initiate Suni and Butch's journey to the space station. There's some history surrounding this mission. So back in 1962, John Glenn flew on the first Atlas, and coincidentally, 62 years later, we're flying our 100th Atlas with Butch and Suni on board. And so that's very significant for our team. When you look at our team, we've been highly focused on the safety of the vehicle, the safety of the payload, as well as Butch and Suni, keeping in our minds them, their families, and the needs of the nation to be able to support this second crewed flight vehicle to space station. Butch and Suni have spent a lot of time in our facilities interacting with every employee within the ULA team, and they've become part of our family as we've moved forward. You know, we see them on a regular basis. They refer to the hardware as their hardware. And it's really means a lot to our entire team to see them, to have them on the call this morning and addressing the team about their readiness and their confidence and our ability to get them to orbit. And so that's extremely exciting, and we're just honored to be playing this part of the mission. For this, we designed 2 different technologies to support human spaceflight. We put an emergency detection system on board that monitors all the vehicle systems, and in the event that we had an off-nominal performance of one of those systems and it required the crew to perform a abort, this will actually automatically trigger that abort. So we monitor those systems and pay close attention to that, as well as designing a dual-engine Centaur, which is really bringing it back from a heritage vehicle that we flew previously and what we're flying in the future. So Vulcan Centaur is also a dual-engine Centaur. So we have that specifically for this mission as well. Going forward, you know, we also have a ascent team that's focused specifically on monitoring the vehicle systems, communicating with our flight operations team in Houston, and relaying that information to the crew throughout the mission. So the team is wholly focused around the crew and crew safety, and really appreciates the partnership and confidence of both Boeing, NASA, and the flight crew to fly on board the Atlas V. Like has been mentioned, the vehicle is very clean. This is one of the cleanest flows that we've had. It's been a pleasure to come to the different flight test readiness reviews, the flight readiness reviews, and not have issues to talk about. We had some minor things that we've worked through, some experiences with coming right after a Vulcan flight into an Atlas, and so we've updated our systems for that transition to be able to continue flying Atlas and Vulcan for the next couple years. So with that, we'll continue to watch through launch as well as landing and recovery of the crew and the vehicle before we deem mission success, but everything's looking great and looking forward to roll tomorrow. With that, Megan.
That sounds all great, Gary. Thank you. And now, Brian, the weather really couldn't be any better, huh?
Yeah, you know, it's generally a pretty good sign when the weather guy has a smile on his face. So happy to bring some pretty good news here. Before I start, I want to acknowledge Dr. Brian Belson. He's leading the launch weather team for this mission that I'm filling in for today, and he's working hard on a lot of these forecasts. But yeah, as I alluded to, the weather looks very favorable here at the launch site for the Monday evening launch attempt. We are still a few weeks away from our summer thunderstorm season here in East Central Florida. And although we are in a bit of a summer-like pattern with an Atlantic ridge of high pressure in control, we don't have the moisture and instability that we might have in a June, July, August. So that will help really limit the amount of showers that are able to develop with the afternoon heating. So on Monday, we expect some light onshore southeasterly flow to start the day. That will help the sea breeze push inland and farther to the west. So any showers that do develop will be out to the west. And then as we get later in the afternoon, into the evening hours, and then after sunset, we'll start to see any of that shower activity begin to die off as we head closer and closer to T0. So overall, The weather does look very favorable here at the launch site, our official launch forecast as of right now. If we could bring that up, that's a 5% probability of violation, so a 95% chance of go here at the launch site. I do want to caveat and say we also work very closely with the Spaceflight Meteorology Group out in Houston that's led by Tim Gardner. And being a crewed launch, there are some additional weather considerations that the entire team is looking at, specifically for crew safety. So they're looking at weather all along the ascent corridor to make sure that we are good to go for launch. So we'll be monitoring that very closely. This percent go here does just encapsulate the weather here at the launch site, and we monitor for a set of rules called the Lightning Launch Commit Criteria that are designed to protect not just against natural lightning, but rocket-triggered lightning. A rocket can actually trigger a lightning strike that would not have naturally occurred. And then as we go to the backup day, in the event that we do have to use the next launch window, weather looks equally as good. Again, a 95% chance of go. But if Mother Nature does throw a curveball at us, the launch weather team will be on console and watching very closely, and we will be ready to go. So, Megan, back to you.
Well, Brian, thank you so much for coming and smiling today. We really appreciate it. All right, so let's head on with the questions. We'll start here in the room. I saw Marcia has 2 hands up. Let's start with you.
I can't decide which hand. Marcia Dunn, Associated Press for Mr. Nelson. What personal assurances have you gotten from Boeing that the safety issues on the airplane side have not spilled over into the spacecraft side? And have you talked directly to Dave Calhoun about any of this?
I've talked to Dave Calhoun many times, not most recently since the aircraft division of Boeing has had the most recent problems with those bolts on the panel falling out. But Dave Calhoun, when I first met him, he introduced me to his new head of Boeing Defense and Space. And he said, this guy is a good one. And he said he is going to make sure that everything is working in that defense and space sector, which includes the Starliner. And my interpretation and observation is just like has been reported to you today, that they have done it without a hitch, that this is a clean spaceship and it's ready to launch. And I can tell you from NASA's point of view, we don't launch until it's ready.
Thank you, Marcia. Over here.
Jeff Faust of Space News. For Gary, besides the emergency detection system and the dual-engine Centaur, is there anything different about this Atlas V from other previous Atlas Vs? Is there hardware or procedures, anything that might account for, as you said, the very clean flow leading up to this launch?
No, other than the emergency detection system and the dual-engine Centaur, the vehicle is pretty much a standard Atlas V vehicle. Goes through the same standard procedures and processes. The only other significant difference is it doesn't have a payload fairing. Instead, we have, as you've seen twice previously, a capsule with an aero skirt sitting on top, and that's all been flight proven and checked out. So we're very comfortable going forward.
Great. We'll take a few more in the room here before going to the phones. James over here in the end.
Thanks, Megan. Hey, everyone. I'm James, our local reporter at Channel 6. For Mark, I was wondering, is the source of your confidence working through all the delays over the last few years? Has overcoming that adversity brought you to this point where you feel as prepared as possible? Thank you.
Well, you know, we go through a pretty rigorous process to get here. And really where my source of confidence comes from is going through that process and getting the alignment that I talked about earlier. We work very closely with NASA, with everything we do from the factory floor to the software to all of our engineering design and our certification products. And we've come to the point where we are all in total agreement. You can't be more confident than that.
Okay. And we have Will over here in the back. And while we're getting the microphone to him, again, just to remind those on the phone to get into the question queue, hit *1.
Hi, Will Robinson Smith with Spaceflight Now. Thanks so much for taking the time, to all of you. Question for Gary. A couple of years ago, before OFT2, you were asked about the process and the progress towards human rating the Vulcan rocket. In that time, have there been any updates towards that? And, what are you looking at with this mission and the successive next 6 flights of Starliner with Atlas that may help inform human rating Vulcan with Starliner? Thanks.
So as we move forward with Vulcan and human rating, we're continuing to do different studies. A lot of the hardware is common. The entire avionics suite is common, and so there's a lot of capability that we have designed into Vulcan moving forward. And as we work with Boeing and other customers on human rating, we're looking forward to the opportunity to fly Vulcan as well with humans on board.
All right, let's go to the phones now. We have Jonathan with Fox News. Jonathan, can you hear us?
Yes, I can. Thanks so much for taking my question. Jonathan Seri with Fox News. My question is about backup launch dates. I believe you said it was May 7, 10, and 11. I'm wondering what times of day are you looking at for each of those dates? Thank you.
Yeah, this is Steve Stich. I can provide those. The first backup opportunity, if we scrub on Monday, would be Tuesday. May 7th, launch would be 10:11 p.m. Eastern Time. And then I don't have the time for the 10th, but we do have the 10th and the 11th, and we can get those times for you.
I do have the May 10th if you'd like to do that. It's May 10th at 9 p.m. and then May 11th at 8:38 p.m. all Eastern Time.
Yeah, thanks, Megan.
Yeah, of course. Okay, we also have Joey Roulette on the phone.
Hi, thanks, Joey Roulette with Reuters. I have one question this time for Dana, Mark, or whoever else wants to answer. What items will the astronauts and ground teams be monitoring during the mission, throughout launch, while it's docked, and during the return? Items that might require redesign for long-duration missions. Like, for example, the batteries on Starliner are believed to be fine for this short-term stay, but they might not be fine for a long-duration stay. Will those and will anything else be examined like that during the mission? Thanks.
I'll start. Well, first of all, it's been said this is a test flight, so all of the spacecraft systems are going to be monitored, and there's really nothing particular that we're going to be looking at that we know today we want to change. We have some things like the batteries that we are working to potentially modify and upgrade. We're really going to depend on the flight test objectives to give us feedback on is there anything that needs to be changed with the vehicle. Remember, we talked about the purpose of this mission is to last time we flew the vehicle it was autonomous. This time we're flying it with people, and we're going to really check that interface between the human element and the vehicle itself. And so we're going to be relying on a lot of that feedback on any future modifications that we want to go make.
And I'll add, I would say there's not major changes we're really planning for Starliner 1. We'll continue to upgrade the vehicle. Boeing has plans to do various upgrades. And one of the things we're going to put in place on Starliner 1 is a little bit better capability for landing in winds. So they've got an upgrade to some of the structure that holds the airbags on Starliner, and that's planned for Starliner 1. But there's the other upgrade I would say is Starliner today can dock to the forward port of the International Space Station. Long term, if you just think about what we just did, right? We moved a spacecraft Dragon from the forward port to the zenith port to accommodate Starliner. For Starliner 1, we'll have the capability to dock at the zenith port, undock from the zenith port, and to also do the port relocate operation. So that's a big upgrade planned in the software. And if you remember what we did back 4 years ago was basically the same thing with Dragon. Demo 2 could only go to the forward port, and then for Crew 1 and subsequent flights, we had the capability to go to either port. So that's the other big piece of software and modifications to the GNC system that we'll have in place.
Thank you both. Okay, we have Micah Maidenberg, Wall Street Journal, on the phone.
Hey, thanks a lot. Steve or Mark, could you talk about preparing for any potential contingencies that may come up during the mission and how Boeing and NASA will be kind of communicating about those and decision making? Thanks a lot.
So I think it's probably twofold. The first is the team that's actually executing the mission. And they train and train and train and train for these contingencies. And they're just well experienced to react to them. So we let them react to them. And we rely on the feedback out of our mission director and Steve's operations manager to give us the information that we need in case we need to help them or we need to communicate across the industry or communicate out. So we have contingency plans in place so that, number one, we're executing them inside our programs and inside our companies, and number two, we're executing across NASA and ULA if necessary.
Yeah, and I would add that really it's been really, even for the long haul, ever since the contract was awarded, about teamwork. And if you step back, the flight control team has flight rules and procedures. The crew has procedures in place for many contingencies. If a piece of hardware fails, then they can use the backup hardware. That's all well practiced, as Mark said. They go through simulations and train and understand those flight rules. It's much like we had for Space Shuttle. And then we have a management team in place, a Starliner mission management team, just like we had for Space Shuttle, where if there was something outside the flight rules or the procedures that we needed to do on the mission, that comes to this forum, which we have on a regular basis, and then the NASA team can weigh in. NASA will be following along the flight step by step. We have people in the control center. We understand the systems. We want to do that to help with crew safety, but also our ultimate goal is to certify this vehicle, for the 6-month increment missions that we'll fly later on. And so we'll have people in place and working side by side with Mark's team. And we've prepared and trained and gone through simulations, and we'll work through anything that comes up.
All right, just a reminder again, if you're on the phone, hit *1 to get into the question queue. But right now, I just want to open up the floor here. Is there anyone with questions? We'll take the one here in the front. We can get a mic to him.
Yusuke Tomiyama, the Yomiuri Shimbun, Japanese Daily. I have a quick question to anyone who can answer. Japanese astronaut Kimiya Yui and Takuya Onishi will fly to the International Space Station around 2025. Let me know the possibility that Japanese astronaut will board on the Starliner after the successful crewed flight test.
Yeah, we do expect, after we get through this certification flight, the crewed flight test, that we would start flying international partner astronauts as soon as Starliner 1. So we already are working with all the international partners, including the Japanese Space Agency, ESA, and Roscosmos as well, to share information so that they can understand the spacecraft. We'll keep doing that in preparation for Starliner 1 and subsequent flights as well.
Great. I saw another hand on this side. Oh, yeah.
This is not from Space TH. My question is almost identical to the previous one. When will we see the Russian cosmonaut fly on the Starliner? Thank you.
Yeah, Dana, would you like to take that question?
I'm sorry, someone was talking over it here. Can you please get it repeated?
Can we get a mic back over?
So my question was, when will we be able to see the Russian cosmonaut fly aboard the Starliner?
Let's see, as Steve mentioned, for all of our international partners, we're going through the process of getting them all of the data that they need to be comfortable with flying their crew members on the vehicle. For this first test flight, all of the partners are just looking at the readiness of the spacecraft and the safety associated with bringing the spacecraft close to ISS, both for the rendezvous, integrated operations, and docking. And so their go and their commitment for this flight is just limited to that. Once we have the results from this crewed test flight, we will share that data with the partnership, and they'll use that to go through their own readiness and approval processes. We expect on the Roscosmos side that they're more likely to want to see a long duration flight also. So we think they'll want to fly with us starting with Starliner 2.
Okay. We have another one in the room here. We have two in the room. Go ahead.
So, Will Robinson-Smith with Spaceflight Now again. I guess to Dana, sort of piggybacking off of that, with Starliner 1 flying in likely spring of 25, if all goes well with this mission, and alternating with Dragon, how will that work with the seat swap without a cosmonaut on the first mission, maybe not until the second? Just if you can clarify sort of the flow of that and what the back and forth will look like moving forward. Will we always see Starliner in the spring and Dragon in the late summer? Thanks.
Sure. We're still working through that with our Roscosmos counterparts. It's our desire to continue to do integrated crew. We think we just have a lot more robust capability overall, similar to the reason why we want different crewed vehicles. It protects for a lot of different off-nominal scenarios. We intend to still fly crew members on the Soyuz vehicle, but we haven't reached agreement yet for that for the overlapping period with Starliner 1. So that's still work in front of us. But the expectation is, even if we can't make that swap work, we'll go back to the integrated crew and swapping for all the rest of the flights. In terms of the cadence of the flights, the idea is once we anchor the first Starliner 1 mission, we will alternate providers, so you'll have Starliner, Dragon alternating back and forth at 6-month intervals.
Thank you, Dana. One in the room here.
Thanks for being here. What are the differences between flying a 2-member crew as opposed to 4? Are there things that you're going to glean and learn from this one that will? Are there big gaps or differences, or is it the same no matter how many number that you have on board? And that probably is for probably Steve.
Yeah, that's a great question. One of the things we're going to do while we're docked is do what I would call a habitability evaluation. So we're going to get extra crew members in the vehicle and just think about, what it would be like with 4 people. I think Butch and Suni will also help us out, right? They'll go through how you sort of live and work in space in Starliner with just those 2, and then I think they're such experienced test pilots and such experienced astronauts, they'll be able to give us a feel for what is it going to be like to have 2 additional crew members. The vehicle itself is designed to be flown really by a single crew member with the ground helping them. And so we always want to have a backup, a commander and a pilot. That's just our heritage and tradition, just like in an aviation industry. But adding a couple extra crew members, it's really about habitability, how are things going to be working, sleep, and those sorts of activities. And I think Butch and Suni will give us a good feel for that after this flight.
All right, let's go back to the phones. We have Gina Sinceri from ABC News.
For Dana, how important is this mission to add robustness to your systems on the space station?
It's a great question. I know you've heard it said by a number of the speakers today, and so I think I'll just share with you an example. When we had the Soyuz leak on board and the Soyuz issue, the first discussion point was, if we need to, how do we safely get the crew home? And in that case, we had plans for contingency coverage. If we had to bring the whole crew home on a SpaceX Dragon, we could have done that. And so the more dissimilar capabilities you have, the more robust you are for dealing with issues that could arise on board or issues, for example, with the launch vehicles. So today we're all launching on Crew Dragon vehicles. We've got the F9. If for some reason there was a problem that could have affected the fleet and you've got to stand down for a while, having another provider is really, really important. The space station is designed to be continuously crewed. We need the crew up there to take care of the vehicle systems. And so if we had a period where we didn't have crew there, we could suffer a lot of degradation to the vehicle itself. And so really, really important for us to have robust and redundant capability to keep us crewed and keep the vehicle healthy.
Thank you, Dana. Also on the phone, we have Tim Fernholz, Payload Space.
Hello, everyone. This is a question for, I think, Mark. I'm just curious, looking at the history of this commercial crew program in Starliner, it's certainly been up and down, and I think we hope to see them fly earlier. But now that we're at the launch pad, I was curious if you could maybe compare and contrast with other Boeing programs you've been involved with and give us a sense of what makes Starliner unique and why it has taken this path to get to the launch pad. Thank you.
Well, design and development is really the phase that we have just come out of and are ending and going into operations. And design and development is like it's constant ups and downs, but the overall slope is always up. So that's where we've gotten to today. We're on the slope we're basically at the top of that slope and now starting to get into operations. It was typical on SLS, the program I was on previously, and then of course I was on shuttle for most of my career in the early days of operations, and it was almost similar, just because you're maturing in the life cycle of operations. So this program has been maturing over the last 10 years. It's pretty typical that a human spaceflight vehicle from design to flying humans is about a 10-year period, and that's where we are.
Okay, we also have Joey on the phone again from Reuters. Joey, can you hear us?
Yeah. This might be I don't know if somebody already said this or if I should already know this, but I'm just curious if someone can speak to how autonomous Starliner is in general. Like, can we put a percentage on that as 100% autonomous? And then, what part of that could astronauts manually take control over in the event of a contingency with one of those systems? Thanks.
Okay, I can start. Well, first of all, it's fully autonomous. We have systems, or we have ability for the crew to take over control, and then we have an additional ability for what we call a backup flight case, where we can totally eliminate the flight computers and fly the vehicle manually. So it's a quite versatile vehicle, and it's designed to have these backup systems and to be a kind of crew-friendly vehicle. Steve, anything to add?
I mean, we demonstrated it is autonomous, right? Orbit Flight Test 2, we demonstrated that autonomous capability with no one on board the vehicle autonomously. Launched, separated from the launch vehicle, from the Atlas V, got on orbit, did a series of rendezvous burns, got close to the space station, and then did the whole rendezvous profile with the software on board the vehicle and then the ground team monitoring it. So it is quite capable vehicle of autonomous flight, but it also, I think as Mark said, has a tremendous capability for the pilot to fly in various modes, and we're going to demonstrate some of those with Butch and Suni during the flight in terms of doing some manual flying toward maneuvering and pointing the vehicle, and then once we get on the final approach to the space station, we get up on that final phase, Butch will make some command inputs and demonstrate the ability to fly Starliner manually. So,
thank you, Mark and Steve. All right, I think there's some more in the room here. Yeah, let's. Who's going to get to him first?
Jeff Faust of Space News again. Question probably for Steve. We had a passing reference earlier to abort weather. What differences, if any, are there in the abort weather constraints for Starliner versus Crew Dragon?
Yeah, good question, Jeff. I would say the abort weather constraints are very similar. Let's just start at the launch pad. We have a criteria we want, if something should happen to the launch vehicle, which we don't expect it to happen in a contingency, the spacecraft can separate, Starliner can separate and then land in the water. So there's a onshore wind component we've got to go look at. So far that's looking really good. And then up the East Coast we have a criteria for abort weather, and so far that's looking fairly favorable. The only differences between Starliner and Dragon are really the staging points are a little bit different. The Atlas first stage, it takes a little bit longer to burn out, and so that staging point's a little further north than for Dragon and Falcon 9. But basically, it's very similar criteria. We're looking at sea states, precipitation, winds at splashdown points, and looking at the overall risk of that for the ascent corridor.
Thank you, Jeff. Marcia, right behind you. Danielle.
Marcia Dunn, AP for Steve, probably. If you launch on the 6th and you dock on the 8th, what's your working date for landing? I mean, what's the earliest you could land? What date would that be?
Yeah, the earliest date right now would be around May 15th. So, and that's essentially the first opportunity after the 8 days, right? We assume we need about 8 days when we look at all the mission objectives that we plan to go do. And so it's around the 15th, but we'll have to look at the weather, and we're also going to look at how things are going in the mission. Is there anything we want to learn? One of the beauties of the manifest that we've executed so far this year is we've laid out this pretty clear summer on ISS to where if we need to stay a little longer, we can at ISS. So, but the 15th is about the first day.
I mean,
we'd have to look at that. We've got, opportunities that are ascending, which is a day landing, and then like the 17th, a day later, it would be a night landing, descending. So, we'll look at the weather. The weather may be a little bit more favorable in the desert after sunset. So we'll look at that, and the descending may be a little bit better. So.
Okay, we'll go back to the phones. We have David Curley, full throttle.
Thanks very much. Mark Nappi, with all due respect, 4.5 years ago plus, we were talking about who was going to capture the flag. You talked about the program maturing. You've gotten there. Can you put a little perspective in that? And since the last time we talked about the long-term future of Starliner, have you had any internal discussions at Boeing, and have any decisions moved closer as to how long the spacecraft will operate? Thank you.
Okay. I'm not sure how to answer your question about maturing. We are to a state now where we are ready to perform the test flight. And I've never felt readier on any mission that I've ever participated in. We are fully aligned with NASA and ULA, and this is a very clean, it's been a very clean last month. So we're mature, we're where we're supposed to be at this point. As far as long-term, yes, we've been working on the long-term plans for Starliner since the 2 years I've been on the program. And there's a number of areas that we had to go look at. Do we need additional spacecrafts? What are we going to do when we transition the vehicle? When are we going to transition the vehicle? And we've knocked a couple of those questions off. What I can tell you is that we have 6 flights to fly with NASA on this contract. That takes us out to the end of the decade. And what we do after that, we have time to make those decisions based on the International Space Station, based on the other space stations that may be put into orbit after that. Those are all things that we need to consider as we go forward.
Okay, last call for questions here in the room. One right here.
John Tilko with Aerospace America. For either Steve or Dana, are you looking at any scenarios to increase the cadence of flights to the ISS, maybe go with shorter crew durations to enable more crews on orbit, as well as up the use of the vehicles for more than just once per year?
Dana, why don't you take that?
Let's see. Yeah, I'll start with that one. We're not going to change the duration of our crewed flights. Our plan is to continue with our 6-month crewed flights, but I know you've seen us do this. We've got private astronaut missions that have a shorter duration. Our intention is to continue supporting the private astronaut missions. Those right now are around 2 weeks long, and of course we run into weather. Sometimes they can be a little bit longer. So we'll continue to try to fit in as many of those missions as we can, but no plans right now to change our crew intervals.
And right now I would add those 6-month flights, it seems about right for that increment relative to when we can get vehicles ready and to go fly. And then also we're collecting, medical data on the crews, and the scientists really want some stable increments to collect that data. So they would like the 6 months to collect how does the crew perform and how do they readapt. And we've flown a few astronauts and cosmonauts out to a year to collect data for Mars. And so some of the data is really driven by maybe the 6 to 1 year duration versus getting those shorter duration medical data. So.
Okay, we have time for one more question. Not seeing hands here in the room. We'll go back to the phone. Joey, take it away.
Hi, thank you. Quick one for Gary or Mark. It's been said that crew rating Vulcan should be pretty easy given its similarities to Atlas, and I was just wondering if you could give a ballpark on how much you think that would cost to crew rate Vulcan given the ease, and who would be the ones paying for that? Would that be ULA, Boeing, or NASA? Thanks.
Gary, how much is it going to cost?
I don't know that we're really prepared to give an exact figure at this point, Joey. We definitely are leveraging all the efforts that we've made to date on Atlas, and we'll work with Boeing to determine there may be some unique requirements that are brought forward that we need to consider, and we'd have to factor that in. But it's using a lot of common hardware. It's got the same RL10 upper stage capabilities. We'd have a new BE4. We'd have to look at that and some of the hazards that are encompassed around that configuration of a vehicle. But whether it's faired or unfaired, those are things that we'd have to work with NASA on the requirements. But
I'll just add, we have been working with Gary and ULA on what it would take to use a Vulcan for additional flights after the 6. And that's what we've been working on for the last year and a half or so, is just understanding what is it going to take. What does the cert flight look like? If we have to do one, what are the changes that have to be made? And so we have a pretty good understanding of that now, and we're just looking forward to making those decisions when it's time.
All right. Well, thank you, everyone, for your questions, your interest in the Commercial Crew Program, in the mission that we're talking about today. As everyone said, we are go for a launch of NASA's Boeing crew flight test with NASA astronauts Butch, Wilmore, and Suni Williams. Again, liftoff is scheduled for 10:34 p.m. Eastern Time, and our live coverage on NASA TV, NASA Plus, and the agency's social media channels. That will begin 6:30 p.m. Eastern, again, Monday, May 6th. So we hope you can join us for this momentous, historic milestone, and have a great rest of your day.